Alright, in this video we're going to talk about quadratic functions in what's normally called the vertex form. Now, most people and most textbooks call this form of a quadratic function the vertex form, although I have seen some textbooks that call this the standard form. Now, I did another video where I talked about the standard form of a quadratic function, which is f of x equals ax squared plus bx plus c. So if you haven't seen that one yet, you should check that one out. There are two different forms of a quadratic function, and a lot of the information that we have here is the same as far as what the graph is going to look like and all that stuff. But with the two different forms, the way we find the vertex of the graph is going to be a little bit different. So you should be familiar with both forms of a quadratic function. So if you haven't seen the standard form yet, or the video I did on the standard form, make sure you check that one out. Right? But this is what we call vertex form, or at least most people call this vertex form. It's f of x equals a times parentheses x minus h squared plus k. Right, where a here is not equal to 0. Right, we cannot have a 0 there, because if we had a 0, all this stuff would equal 0, and we would just have some number k, and then that would not be a quadratic function. That would just be a constant function, is the horizontal line. All right, so h or k or both of those could be 0, but a, that coefficient out in front, could not be 0. All right, so when we graph a quadratic function, no matter which form it's in, whether it's the standard form or this vertex form, when we graph it, we get a parabola. Right, which the two shapes down here are parabolas just facing in opposite directions. Right, so when you graph a quadratic function, it's going to look like one of those two graphs. Its placement might be moved around, obviously, but it's going to look something like one of those two graphs. Right, and the vertex of our parabola is at the point h comma k. Now, if you watch the other video I did about the standard form, the ax squared plus bx plus c, there's a little formula to find the vertex. X equals negative b over 2a. Right? When we have the vertex form, and the reason the vertex form is so convenient for us to use sometimes is that this h and this k here that are right there in that vertex form, they give us the x and y coordinates of the vertex. Right? X minus h, whatever that number is, that's the x coordinate of my vertex, and then plus k, whatever that number is, there's the y coordinate of my vertex. I don't need to know any special formulas or do any work to figure it out. The two numbers I need for the vertex are right there in the function. Right? That's why we call this normally the vertex form, because the vertex it's right there for us to read. We just have to know which number is the x and which one is the y. Right? The one little thing to be aware of here, it's x minus h. So if my function said like x minus 5 parentheses squared, well, my h is 5, not negative 5. Right? The minus is part of the form of the equation, so it's kind of the opposite sign of what's in here is the x coordinate of your vertex. If this said x plus 5, then my h would be negative 5. Right, the k is normal. So if it says plus 2, my y coordinate is positive 2. If it said minus 4, my y coordinate would be negative 4. Right, the x is like the opposite sign. The y is the normal sign. Right, but that's the only tricky thing really about the vertex form is remembering that it's x minus h. So you have to use the opposite sign of whatever that number is to get your vertex. All right, so that's how we find our vertex. Now, our graph, like I said, is going to be one of these two ways. It's either going to be facing upward or facing downward, right? And there is another number in our function that tells us which way it's going to go. And it's that leading coefficient, that's that's out in front of that parentheses. Whether that number is positive or negative will determine the direction that our parabola faces, all right? And again, if you watch the video that I did on the standard form, which was ax squared plus bx plus c, well, that a that's in front of the x squared in the standard form is the exact same a as what's in front of the vertex form. That's why they use the same letter for the two different formulas, because it's the same number. If you switch, if you switch a quadratic function from vertex form to the standard form or standard to vertex, that number a is the same in both of them, right? So just to point that out, if you watch that one on the standard form and you remember the rule for whether a is positive or negative, it's the exact same rule for vertex form, right? So if that's a positive number in front of my parentheses there, if a is greater than 0, then we have one of these upward-facing parabolas that opens upward, and our vertex is a minimum point. Right? The vertex there at the point h comma k would be a minimum if that number a is greater than 0, if we have a positive number in front of the parentheses. On the other hand, if we have a negative number in front of the parentheses, if a is less than 0, that's when we have that downward-facing parabola. Right? It opens downward, in which case our vertex is actually the maximum point on the graph. Right? So whether that leading coefficient is positive or negative, it tells you already which direction the graph is going to go, and then the h and the k, the other numbers in that function, tell you where the vertex is. Right, so having a quadratic function in the vertex form is pretty convenient because a lot of the information you need to know what the graph looks like is contained right there in the numbers that you see in the function. Right, whereas in the standard form, that a is still there, so the a still tells you which direction it goes, but in order to find the vertex, you have to like use a little formula to figure out where the vertex is. So for the standard form, it takes a little bit more work to find the vertex. All right, one other thing I want to point out on this here is if you watch any of the videos that I did on transformations of functions, the vertex form is directly related to the transformations of the graphs of functions, and I'll explain how that is. Right, so first off, our parent function here would be an x squared. It would be the quadratic function because here we have an x being squared. Right, so our parent function would be the basic parabola with a vertex at the origin. That's the graph of y equals x squared. That's the parent function that we're dealing with here. Right, now this minus h, right? Remember, if there's a number being added or subtracted inside the parent function with the x, right, which this minus h is inside that second power function, so it's in there with the x, right, that's our horizontal shift to the left or to the right. And remember, it goes in the opposite direction, right? So a minus h actually means we move to the right h units, which means I take my vertex from wherever the origin is from 0, and I move it to the right h units. Well, now my vertex is at x equals h, right? I slide it to the right h units. Right? The plus k, the number added or subtracted outside of the parent function, is our vertical shift up or down, right? And that one goes in the normal direction. So plus k means you move up k units, right? So I take my vertex from 0, 0, I go to the right h, I go up k, that's where my new vertex is. Our vertex is at h comma k, right? So if you remember those rules for transformations of the graphs of functions, and if you don't remember them, you can check out the videos I did. I did several videos on all the different rules for transformations, but getting that vertex at h comma k, that's a horizontal shift to the right h and then up k, and that takes us directly to where the vertex is, no matter which direction the parabola goes. In this case, it's over h, it's up k, and there's my vertex. Right, so the vertex is really just that horizontal and vertical shift, and the h and the k are the numbers that give us that when we're doing transformations of graphs. Now, the a in front, remember, if there's a positive or a negative in front of our parent function, that's the reflection over the x-axis, right? That flips the graph over, right? If this is the graph of x squared, the graph of negative x squared looks like that, right? It's the same graph, it's the same shape, just flipped over and going downward instead of upward. Right, so that ties into the rule here for which direction the graph goes. If a is greater than 0, if it's a positive number, I don't do the reflection, I don't flip it over. If a is less than 0, that means there's a negative in front of my parent function. That means I do the reflection, I flip it over, and so my parabola is opening downwards. Right, so if you are familiar with the rules for the transformations of graphs, and if you remember what those rules are, well then all the stuff we talked about here is just applying those transformations to the graph of a quadratic function. And we've got, like if you saw some of the other videos that I did, we actually did stuff like that where I had a quadratic function, I slid it left or right or up or down or had to flip it over. So nothing really new here, just kind of giving it a different name, saying this is the vertex form of a quadratic function. The vertex is at the point h comma k. But if you approach it just as a transformation of graphs, that's all you're really doing here to draw the graph of a function when you have it in the vertex form. All right, so that's about all I have to say about the vertex form of a quadratic function. Remember, I did another video where I talked about the standard form, so you also should check that one out because the two different forms, sometimes you have one, sometimes that you have the other, so you have to be able to be familiar with both of them. And I'm going to make another video now where I actually do an example of, here's a quadratic function, let's find the vertex, let's figure out which way the graph is going to go, let's see what the graph looks like and actually draw a picture of the graph. So check out that video as well where I actually do an example of working with a quadratic function and figuring out all the information we've been talking about its graph.